Dr. Joshua Schiffman, a pediatric oncologist at the Huntsman Cancer Institute and at Primary Children's Hospital. Thanks so much for being part of Three Questions today.
Thanks for having me.
How big a deal is this, really?
Well, I think what's so big about this discovery is its potential and the hope that it provides. These elephants, these amazing animals, have had 55 million years to develop the perfect cancer-fighting protein. The same p53 gene that you and I have, 2 copies, these elephants have 40 copies, and their extra copies have been modified over these 55 million years. And so what's so big about this now is the potential, the hope it could provide to our patients. These elephants have figured out how to resist cancer, and now the challenge is to figure out how do we apply this to people.
So what's next in your research?
Yeah, so this is a really exciting time. First it was thrilling to discover why these elephants rarely develop cancer, but now we've taken the next step. Working with colleagues actually around the world, in this case from the Technion Israel Institute of Technology, we're trying to develop a new medicine to figure out how do we take that protein, that p53 cancer-fighting protein, from the elephants, synthesize it in the lab, and put it into a nanoparticle, a tiny little lipid ball where we could actually deliver it as a medicine to people. And what we've started to see is that in the laboratory, in the dish, cancer cells that come from people growing right there in the lab, when we put in elephant p53, the cancer-fighting protein from elephants, these cells are being wiped out. They are completely dying. And that is very, very exciting.
Why can't you say that this is a cure for cancer just yet?
Yeah, well, there's a few reasons. The first is, as a pediatric oncologist, as someone who sees patients with cancer, and especially families who have cancer or are at risk for cancer, we never, ever, ever want to overpromise and underdeliver. Too often, we hear in the world of medicine, this is it. This is the cure for cancer. And we're not saying that at all. What we are saying, though, are that these elephants, they've found the cure for cancer in elephants. That we believe. And what we're trying to see is, can we take that? Can we learn from what nature has already discovered and nature has already perfected and figure out how to apply that to people?
How are cancer cells in an elephant different from cancer cells in a human being?
Well, what we think is that the elephants, because of their extra copies of p53 and the way that these p53 proteins have been modified over time, we believe that what they do is when the cells in an elephant begin to turn into cancer, or precancer, if you will, that their p53 springs into action, wipes out those cells before they go that next step and actually turn into cancer. And what's so remarkable about this is, if you think about elephants, 100 times the size of people, living 50, 60, sometimes 70 years, that many cells dividing decade after decade after decade, just by chance alone, all of the elephants should be dropping dead of cancer, but they rarely do. And that's why we think that the elephants have evolved these extra copies of p53 to protect them, to avoid having cancer cells in an elephant.
Will the cure for cancer come from Utah?
Well, we certainly would hope that, and of course, myself and all of the other investigators doing amazing research at Huntsman Cancer Institute go to work every single day to try to figure out just that. How do we cure cancer? But I'll tell you, what I'm even more interested in than treating cancer and curing cancer is figuring out how to prevent cancer. As a pediatric oncologist, as someone who takes care of children, in pediatrics, we'd much rather prevent disease than treat disease. And we know the elephants, with their extra copies of p53, they have figured out how to prevent cancer. So the hope is, once we figure out how to treat cancer with this elephant p53, can we figure out a way to get it into people and use it in such a fashion that it could one day possibly prevent cancer? Now, we're not there yet, but of course that's what we dream about at night.
How close are you to clinical trials in human beings?
Well, what we think, Bob, is if we can get enough funding to get this project really going, that we've mapped out a way that in the next 3 to 5 years, we actually believe we could begin our first in-human trials. Now, yes, your eyes have gone wide up, and that's remarkably fast. But the reason that we think it's so fast is that we've been studying this protein for many, many years. In fact, there have been 30 years of research, even longer, behind p53 and figuring out how to make this a medicine for cancer. It's really, p53 has been the holy grail in terms of how to fight cancer. And Dr. Schroeder, who we work with in Israel, develops nanoparticles. What he does is novel drug development and delivery. And he's figured out how to manufacture the elephant p53 with us here at Huntsman Cancer Institute at the University of Utah, load it into these nanoparticles and start delivering it as a drug. So all of the pieces are in place. What we need to do is, now that we've seen it's working remarkably well, better than we could have imagined in the dish, is move on and see what happens when you give it to a living animal with cancer. So in the world of cancer research, usually we start with mice in the lab who have cancer, and we see, can we cure these mice of cancer? Sometimes we can even figure out a way that these mice have human cancer, and can we cure mice with human cancer? And that's very exciting. But we want to take the next step, and we want to figure out, can this work actually in pet dogs? Now, this is very important to clear up. We never would give cancer to dogs. I am a dog lover. I have 2 dogs. We were talking today, almost everyone in our lab, Bob, has at least 2 dogs. So we love dogs, but dogs get an awful lot of cancer. And what we wonder is, could this elephant p53 be a way to help treat dogs with cancer instead of having to put them to sleep? And if it works well in dogs, well, that's fantastic. That does 2 very important things. One, it helps us get closer to trying it in people, because the dogs are getting the same type of cancer that people get. But then also, maybe this will be a new drug that can help fight cancer in dogs, and wouldn't that be wonderful?
There are a lot of families that at this news are full of hope. But for them, the wheels of research turn so very slowly. Why is it that the research wheels turn so slowly?
Well, you know, we want to be very safe, and sometimes we're overly cautious in the field of medicine. You know, as a doctor, we say, first, do no harm. And we want to be careful that this is actually something that's going to work. You know, people have started calling us up and saying, Dr. Schiffman, can we have some of your elephant p53? And although we would love to do that, we want to make sure it's safe. We don't want to have unintended consequences, give this as a medicine to people without first making sure that it's safe. We don't want people dying from our medicine that we give to them. We want this medicine to treat and maybe even one day prevent cancer. So we have to be very careful and make sure that it's safe to give. But I do want to come back to what you said about hope. And that's one of the things that's so remarkable about doing this research. As you know, this discovery came in collaboration with Utah's Hogle Zoo and even the Ringling Brothers and Barnum Bailey circus elephants. And you know, there in the zoos and in the circus, they draw blood from their elephants on a regular basis to make sure that the elephants are healthy. And working together with these organizations, when they were drawing their blood for their own reasons, we were able to get some of it in the lab to study. Now, the medicine we're using now and we're creating is synthetically produced, so we don't take it from the blood from the elephants. But what's so remarkable is when you're sitting in the room with patients and families and there's a new diagnosis of cancer, we're able to now say, hey, did you know that we're working with Utah's Hogle Zoo and the Ringling Brothers and Barnum Bailey Circus to try to learn from these elephants to one day hopefully help you and other children and families with cancer? And suddenly the mood in the whole room shifts. And instead of one of darkness and despair and fear and anxiety, suddenly people start giggling and laughing. Elephants? We love elephants? You mean elephants might help with cancer? And everything shifts. And it's that hope that we're providing that's just so very rewarding.
Kinds of cancers.
Yes.
Which cancers is the p53 gene most effective against?
Well, you know, this is the remarkable thing. p53, as it turns out, is involved in almost every type of cancer known to humankind. And it is broken, missing, not working, breast cancer, brain cancer, lung cancer, colon cancer, you name it, and P53 is not working. P53 is like the police of the genome, the guardian, the superhero of our DNA. And so if it's not there, if the police are missing, then the cell turns into cancer. And so what we've seen so far is in every type of cancer that we've been testing in the dish, there seems to be a response. Whether it's a very deadly glioblastoma or brain tumor, whether it's breast cancer, prostate cancer, lung cancer, melanoma, skin cancer. In fact, just over the weekend, we saw that it was effective in the dish in pancreatic and ovarian cancer, two very, very deadly cancers. Yeah. So we are excited beyond belief. People in my lab are working around the clock. They're there on weekends, they're there after hours. People even, I've seen them bring their kids into work while they're pipetting. The kids are dancing around their legs because everyone is so dedicated and so full of hope at the Huntsman Cancer Institute, and not just the work we're doing, that everyone is doing, that together as a community, we can actually bring about change.
So to say that you are optimistic is perhaps an understatement.
I would say it is. I would say it's definitely an understatement.
What could go wrong at this point?
Well, this is why we're doing the research, and this gets to your earlier question of why does it move so slow? We have to be realistic, right? As I said, we're very careful to say this is extremely promising, but we haven't done it yet. This is not yet the cure for cancer. We need to test it out and see where it will go. What could go wrong? Well, we could give it to a living animal, we could give it to mice, and all of the mice could suddenly drop dead for reasons we don't understand and we need to explore. Just because it works in a dish doesn't mean it's going to work in a living animal. And in fact, often it doesn't. But what we're seeing just seems so incredibly promising. And we know that this drug delivery system works with other types of medicine.
In light of the discoveries you've already made and the exciting news that it has created, how difficult do you think it will be to raise the $20 million you need to get to human clinical trials?
Well, that depends on the community and how generous people are feeling. You know, this is really a type of impactful or philanthropic donation. You know, my focus is trying to make a difference, trying to make an impact. When I was 15, I myself was actually diagnosed with cancer. And as a cancer survivor, as someone who takes care of children and families with cancer, and as a cancer researcher, what I can tell you with a fair degree of certainty, Bob, is that one person with cancer, whether it's a child or an adult, is one person too many. We want to see this in the clinic, not tomorrow, but yesterday. We don't have time to wait. Every day that goes by is another person who's diagnosed and yet another person who's dying of cancer. And we feel that here we have some hope. And we don't know if it's going to work or not, but if I didn't believe it, I wouldn't be trying so hard. And something this important, and all of us feel this way in cancer research, we're obligated to try. We're obligated to see if this will make a difference.
Dr. Joshua Schiffman, pediatric oncologist from the Huntsman Cancer Institute and Primary Children's Hospital.
Thanks so much.
Thank you so much for being part of Three Questions.
Absolutely.